Hello students, welcome to the topic differentiability. In this video, I am going to discuss parametric functions and derivatives of parametric functions. First, let me discuss about the parametric functions. Consider a function. This function may be standard function, composite function, or it may be implicit function. There are two variables in this function, x and y. And these variables, x is given by one function and y is given by another function using another variable t or theta or maybe any other variable such that it satisfies the given function. Then these functions are called x and y parametric functions of the given function. For example, let me take one equation, x square plus y square is equal to r square. That is a equation of circle. The parametric functions of this equation are given by, that is, x is equal to r cos t and y is equal to r sin t. So these are x function and y function. Now these two functions, if I substitute in this expression left side, it gives the r square only. Therefore, these functions are called as parametric functions of the circle equation. Okay, let me verify this one by simplifying. Let me take LHS and substitute x means r cos t whole square plus y means r sin t whole square, and squaring this one you will get r square cos square t plus r square sin square t. Taking r square common, you will get cos square t plus sin square t, so which is nothing but one number. Therefore r square, and that is into 1, therefore it become r square. So and this is nothing but RHS. So which means that these two are nothing but parametric functions, which means that these two functions r cos t and r sin t represents circle equation only, but these are called as parametric functions or parametric equations of circle equation. I hope you got it, students. Now in this video you are learning, if these functions are given, that is x and y parametric functions are given, then how to find out dy by dx, so that you are learning. So let me first define how the derivative dy by dx is given if parametric functions are given. If x is equal to function of t and y is equal to function of t variable where t is parameter, then dy by dx is given by, that is derivative of y function with respect to x variable is given by like this. Y is function of t, so differentiate this y function with respect to t, and x is function of t variable, therefore differentiate this also with respect to t variable and divide it, that become dy by dx. Therefore dy by dx is given by dy by dt divided by dx upon dt. So here dt and dt get cancelled, it become dy by dx equivalent. So therefore dy by dx answer, we find it differentiating y function with respect to t variable and x function with respect to t variable and then dividing. So this is the way of finding dy by dx. Now see the examples. If x equal to a cos t, y is equal to a sin t, then find dy by dx. First you write given functions, x equal to a cos t and y is equal to a sin t. So x is a function of t variable. What is the function? A cos t. And y is also function of t variable, that is a sin t. Already you know that these two functions are parametric equations or parametric functions of circle equation. Okay, so now differentiate these two functions with respect to t variable. Okay, so with respect to t variable means x is a function now dx upon dt, left side equal to, see here variable important dt. Okay, don't write x, constant a as it is. Now cos t is a standard function t variable, cos t derivative become minus sin t. So rewriting this you will get minus a sin t. Similarly you differentiate y with respect to t variable, that is dy by dt equal to a constant sin t derivative cos t. So rewriting this one a cos t. So now dy by dx equal to, you know the formula, dy by dt divided by dx upon dt. So what is dy by dt function answer? It is a cos t dx upon dt minus a sin t. So in this a get cancelled, so you will get a cos t divided by sin t, it become cot t. So therefore answer is minus cot t. So this is the dy by dx answer, and this is the method of finding dy by dx function if parametric functions are given. Now see the next question. If x equal to 2at square, y is equal to a t raised to 4, then find dy by dx. First you write a given function x equal to 2at square and y is equal to a t raised to 4. So differentiate with respect to t. So left side become dx upon dt, and 2a is a constant, t square is 2t. So simplifying this one, 4at, and y function differentiation with respect to t, that is dy by dt, a constant, t raised to 4 derivative 4t cube. So rewriting this you will get 4at cube. So now you write dy by dx, dy by dt divided by dx upon dt. 4at cube divided by 4at. In this 4a get cancel, you will get, and t cube and t, in this also one term cancel, so you will get dy by dx is equal to t square. So this is the dy by dx function answer. And one more point, remember students, here x is given by one function, y is given by function. These functions may be standard functions in t variable. These two functions may be composite, or you may get substitution technique. So whatever the form we get, using that form we differentiate. Okay, now we are getting simple form, single functions. So easily we are finding differentiation. You may get next the function in terms of product, division, whatever the form may be, substitution, whatever the form you will get, that form using you have to differentiate. Next example, if x equal to sin t, y equal to cos 2t, then find dy by dx. So here in this example y is cos 2t, this is composite, this is simple function, so standard function, so easily you can find derivative. First write given functions. differentiate with respect to t. So that become dx upon dt is equal to cos t. Okay, rewriting it is cos t only. Dy by dt is equal to cos 2t derivative. It is written as first cos function derivative. You know it is a trigonometric composite. First we write the derivative for cos, that is minus a sign, keep the variable as it is, that is minus sine 2t. After that 2t variable derivative. So with respect to t means it's become 1. So therefore 2 into 1 means it is 2. I hope you got it. So rewriting this one, it become minus 2 sine 2t. So now you write dy by dx. Dy by dt divided by dx upon dt. That is equal to, what is the dy by dt function answer? Minus 2 sine 2t divided by cos t. Minus 2 as it is. Now here this function we can simplify. So here we can use the identity sine 2t function, that is a 2 sine t into cos t divided by cos t. Cos t and cos t get cancelled. So you will get minus 4 sine t. This is the derivative answer. Now see the next example. If x equal to cos theta minus cos 2 theta, y is equal to sin theta minus sin 2 theta, then find dy by dx. Now the parametric functions are given using theta variable. So what is the variable of the functions? Theta, not t variable, theta variable. First write given functions, differentiate with respect to theta. So this is very important. Variable you have to observe. So now dx upon d theta is equal to cos theta function derivative minus sin theta minus as it is. Now cos 2 theta, this is composite. First cos function derivative, that is minus sin 2 theta. After that 2 theta derivative is 2. So simplifying, you will get minus sin theta and minus into minus. This minus into minus become plus and 2 sin 2 theta. Similarly, y function derivative, sin theta derivative cos theta minus sin 2 theta function derivative is cos 2 theta into 2. So dy by d theta is equal to cos theta minus 2 cos 2 theta. Dy by d theta divided by dx upon d theta, that is dy by dx. So substitute dy by d theta, cos theta minus 2 cos 2 theta divided by minus sin theta plus 2 sin 2 theta. So here you should know the combination of trigonometric functions, which functions we can simplify or we get a simplification. Okay, here cos 2 theta is there, sin 2 theta is there. Okay, so here sin 2 theta you can use write as a 2 sin theta into cos theta, but we cannot get any simplification. So therefore you can keep this answer as it is. So further simplification is not required. You will not get any simplification here. So therefore this is the final answer. Next example, if x is equal to a into bracket theta plus sin theta, y is equal to a into bracket 1 minus cos theta, then find dy by dx. So first you write a given function, x is equal to a into bracket theta plus sin theta and y is equal to a into 1 minus cos theta. Differentiate with respect to theta. So left side is dx upon d theta. So in this x function, a is a constant, theta derivative is 1, this theta derivative is 1 and sine theta derivative is cos theta. And rewriting this one, you will get a into bracket 1 plus cos theta. dy by d theta, a constant as it is, and what is the derivative of 1? It is a constant, but theta with respect to we are differentiating, this is 1. So therefore derivative is 0 minus, and cos theta derivative is minus sine theta. Use the bracket and write, because behind this you have a minus. So rewriting this one, it become a sine theta, because minus into minus plus. So this is dy by d theta function. Now dy by dx is equal to dy by d theta divided by dx upon d theta. What is the dy by d theta function? Substitution, a sine theta, a into 1 plus cos theta. Okay, now here a get cancelled, and also we can simplify this trigonometric combination, sine theta and 1 plus cos theta. Students, you have to remember this combination simplification. So this combination you will get in integral chapters many times. So you should know how to simplify this combination. So in this combination, sine theta function is written as 2 sine theta by 2 into cos theta by 2 divided by, and 1 plus cos theta function is written as 2 cos square theta by 2. So this is sine theta is written as 2 sine theta by 2 into cos theta by 2 using or following that sine 2 theta. There is a 2 theta, half of that. Okay, and this is 1 plus cos 2 theta. 1 plus cos 2 theta means we have a 2 cos square theta. So 1 plus cos theta means make the angle half, 2 cos square theta by 2. So using that identities, so the functions substitution is written, and then here 2 get cancelled, 1 cos function cancel. So you will get sine theta by 2 divided by cos theta by 2, and this can be written as tan theta by 2. And this is the solution. So here important is remember how to write the sine theta function and 1 plus cos theta function substitution. Next example, if x is equal to a into bracket cos theta plus theta sine theta, and y is equal to a into bracket sine theta minus theta cos theta, then find dy by dx. Given functions x equal to a into bracket cos theta plus theta sine theta, and y is equal to a into bracket sine theta minus theta cos theta. Differentiate these two functions with respect to theta variable, that is dx upon d theta is equal to, now a is a constant, put the bracket, cos theta function derivative is minus sine theta plus, now next is theta and sine theta, we have a product form. So this product we have to write the derivative using the product rule, that is keep one term as it is, that is theta as it is, differentiate sine theta, that become cos theta, plus now sine theta as it is, theta derivative is 1, and complete the bracket. So this is the product rule. So simplifying, you will get a into bracket minus sine theta. So here it is a plus sign. So if you multiply to this bracket, the function becomes same, that is theta cos theta plus sine theta. So here plus sine theta minus sine theta, it becomes 0, that is it cancels, it becomes theta cos theta, single function, a into theta cos theta. This is dx upon d theta function. In the same way, dy by d theta, a as it is sine theta derivative cos theta minus, now here use the bracket because 2 To write the derivative of this, we have to use the product rule. So in the product rule, we have a addition. So therefore use the, and here negative sign. So therefore use the bracket and write the product rule. Keep theta as it is, cos theta derivative minus sin theta plus cos theta as it is, theta derivative is 1. Okay. So further simplification, a as it is, cos theta. So this multiplying negative sign through the bracket, it become minus into minus plus theta sin theta and minus cos theta. So here also cos theta and minus cos theta become 0. So it is a into theta sin theta. So this is dy by d theta function. So now you know that dy by dx given by dy by d theta divided by dx upon d theta. Substitute dy by d theta, a theta sin theta, a theta cos theta. So a theta numerator and denominator get cancelled. It become tan theta. So this is the dy by dx function answer. I hope you got it, students. Now next example. This also very important examples. If x is equal to a into bracket cos t plus log tan t by 2, y is equal to a sin t, then find dy by dx. So here the x function is a little bit complicated function. Y is very simple, a sin t. Okay. And functions variable is given t. Here you can see that cos t log tan t by 2 sin t. Variable is t. First you write given function. Differentiate with respect to t. That is dx upon dt. A as it is. Cos t derivative is minus sin t. Plus, now this function derivative. So first you identify it is a which type of composite. It is a which type of function. It is logarithmic composite. Here you can say that log of function we have. So log of a function, how it is followed? 1 upon function, that is tan t by 2, and after that tan function derivative. So tan function variable, you see it is t by 2, it is not t, therefore again it is composite. So therefore here first you write tan function derivative, that is second square, keep this t by 2 as it is. After that t by 2 derivative, you have to write what is t by 2 derivative. 1 by 2 constant. So 1 by 2 constant. T term derivative is 1, therefore it is 1 by 2. So 1 by this function, after that tan derivative, after that t by 2 derivative. Once again I repeat, log function derivative, that is 1 upon function, after that tan function derivative, after that t by 2 term derivative, 1 by 1. Complete the bracket. So this is a into bracket minus sin t plus, now tan means sin upon cos, that cos goes to numerator, that is written as cos t by 2 divided by sin t by 2. And you know that second function relation in terms of cos, it is 1 upon cos, therefore it is written as 1 upon cos square t by 2 and 1 by 2 as it is. Once again I repeat, here tan t by 2 is written as sin upon cos, that cos goes to numerator, therefore cos t divided by cos t by 2 divided by sin t by 2, and second t is written as 1 upon cos square, second t is 1 upon cos and 1 by 2. Here one cos function get cancelled, you will get a into bracket minus sin t 1 divided by sin t by 2 into cos t by 2 into 2. So dx upon dt is equal to a into bracket minus sin t plus 1 divided by, now look this expression students, already In previous example, you written sine theta is equal to 2 sine theta by 2 into cos theta by 2. Okay. Now we have that right side 2 sine t by 2 into cos t by 2. So this product is written as sine t. Okay, reverse it is. You have to remember all these expressions. These are very important. 2 sine t by 2 into cos t by 2 is written as sine t. In previous example, we written reverse sine t, sine theta. Sine theta is written as in half angle formula. Now reverse, right side you have to write left side. So now dx upon dt is equal to a into bracket. If I take LCM here, so this sine t function is multiplied to this sine t, it become minus sine square t plus 1 divided by sine t LCM. So dx upon dt is equal to a into bracket. So numerator is nothing but 1 minus sine square t. 1 minus sine square t is nothing but cos square t divided by sine t. Now I am going to write a y function derivative. Dy by dt is equal to a as it is. Sine t derivative is cos t. It is a simple function. So easily you can write a dy by dt function. Now you write dy by dx. It is dy by dt divided by dx upon dt. So it is a cos t and dx upon dt a cos square t divided by sine t. A get cancelled and cos t get cancelled. So you will get and sine t goes to numerator. This sine t goes to numerator. So it becomes sine t divided by cos t. So that is nothing but tan t. So this is the derivative of the given function. Now another example. This is also very important example. If x equal to root of a raised to sine inverse t, y is equal to root of a cos inverse t, then prove that dy by dx equal to minus y by x. So this example we can prove that in two ways. One is following that parametric forms, finding dx upon dt and dy upon dt. Otherwise, simplifying this function, easily we can find dy by dx. In any manner we can find. So here the function is a root composite function, root of f of x, both. Okay, so if I find dx upon dt, dy upon dt, you have to follow that one. So that is little bit difficult. Now see, easy method is first you write given function. Here I am not finding a derivative directly. I am simplifying this, multiplying the equations. So let me multiply these two equations. X into y is equal to root of right side also multiply root of a sine in a raised to sine inverse t into root of a raised to cos inverse t. So right side we can take a common root of a raised to sine inverse t into a raised to cos inverse t. Okay, so taking common only one root and multiplying this. Now base is a, same. So therefore using laws of indices, right side this can be written as a raised to powers are added, that is a raised to sine inverse t plus cos inverse t. So now in inverse trigonometric topic you learned that sine inverse t plus cos inverse t, this addition is given by pi by 2. So therefore it is written as a raised to pi by 2. Now I differentiate this equation. This becomes simple. X into y is equal to root of a raised to pi by 2. This is constant now. So left side it is x into y, that is a product. So using the product rule you have to write the derivative. X as it is dy by dx. Now I'm not differentiating with respect to t variable because this is function in terms of only x and y variable. So differentiate with respect to x, dy by dx plus y as it is, x variable derivative is 1, and this is a constant right side, this is constant, so its derivative is 0. So now right side you transfer, you will get x into dy by dx equal to minus y. So dy by dx is equal to minus y by x. So very easily you will get that right side. I hope you understood, students. Thank you.